Good morning, class. Welcome back to our GeoGebra class, and today we will mark our fifth day of using GeoGebra to take care of mathematical problems. And then, basically, what we are doing is not anything much. What we are going to do today is how to differentiate, or you doing differentiation and also doing linear programming. So we all know that differentiation is just finding the derivative of functions, which basically represent the instantaneous change of those functions at a given point of time. And then we all know, so today we are only going to pick like 3 functions, and then we find the derivative of it using GeoGebra. We're going to pick the sine function, and then a cubic function is a quadratic function. So we all know that when we differentiate a sine function, we basically be getting a cos function. When we differentiate a cubic function, we'll be getting a quadratic. When we differentiate a quadratic, we'll be getting a linear. So basically, those are what we'll be doing, right? So basically, when you input your function, GeoGebra plot it for you. So we are going to use the graph to demonstrate all those things. So first, I don't need the graders. I just want empty space. So the first function I promise you are going to use is the sine function. So we are going to enter sine. Just pick the sine function. So our function is going to be x. So you can see what GeoGebra have done for you, right? You want to see this how the sine function looks like. The sine function between. So what we have to do is just go to the input button and type our derivative. So this is a function we are picking. This is a function we are picking. So we just find the sign of that. Just find the sign of. So we are just going to find the derivative of it. Just type derivative, and then to appear, and that is the derivative of a function because it's a function that we are using. What's the name of our function? Our name of our function is f. So you can see when you type it, f prime of x, which gives you cos. So when you differentiate sine, you get cos, and this is the graph of it. So for sine, it's represented in a green. So this is a graph of sine. So when you differentiate sine, you get what? Of course. So GeoGebra plot it for you direct. Right. So let's move on to another function. So let me hide these functions here. So let me pick the cubic function, which is x cubed. Let me pick the cubic function, which is x cubed. The cubic function, which is x cubed. Let me pick the cubic function. That is x cubed. So you have to here. You'll see your x cubed here. Right. So this is basically the function of a cubic function, the graph of a cubic function, how it is being represented. Now you just go to the input, type the derivative of that function. What is the function that is function g? So we all know that when you differentiate a cubic function, you are going to get a quadratic function. So you can see the graph of the quadratic function. So the cubic function is represented in blue, and then which is this function here. So when you differentiate x to the power 3, we are getting what? 3x squared. So which is that graph? And then move on to, let me hide this one to then I'll bring in a quadratic graph, which is x squared. Bring in the x squared here. So you can see this is the graph of the quadratic function in the U shape. So let's just type the derivative of that function. So the function is of function h. You can see we had a straight line. So basically, this is how we do differentiation in GeoGebra. It's not anything. So you can see that for the sine, when differentiate sine, which is this function. When you differentiate, you are getting what? Cos function. This is the line in red. And then when you differentiate a cubic function, you are getting a quadratic function, which is like this. And then when you differentiate this thing, quadratic function, you are getting a linear function. Which is this. Now let's try a linear function and see what it will give us. So let's say x. So then this, right? Let me now differentiate the derivative from the function p and see what we'll be getting. We are going to get what? A number, right? A constant. So the derivative of the function p. So you can see it's a straight line. It's a straight line, right? So basically, this is how we do the differentiation. So move on to the linear program, and I'll use a different window for it. All right, so this one too, I don't need a read. Yes, basically is what I mean. So we all know that a linear programming is a mathematical technique used to optimize. When I mean optimize, either we are minimizing or maximizing a function or a linear function, which is involve two functions. It talks about the objective functions and then the constraint functions. What do you mean by objective functions? So for the objective function, they are function that you want to optimize, or the objective functions are the function we are going to optimize. And when in the process of optimizing it, then we will be given some conditions or rules. So the conditions also will be in the form of a function. And those functions that we tend to be what? The constraint function. Are we okay? Those are the functions we tend to constraint functions. So in conclusion, what basically linear programming is, provides a structured approach in making optimal decisions in situations where the relationship between them must be linear. If it is not linear, then it is no more a linear programming. Right, so the goal of it is to either maximize or minimize a specific outcome while adhering to a specific rules or guidelines, which are the constraint function that will be given to you. Okay, so we are here, we are going to use a question to do this. We are going to solve a linear programming related question for me to use to demonstrate all what we are trying to do, how to solve those linear programming questions in GeoGebra. So basically, that's what we are going to do today. So I'll be giving the question. So here I'll provide the objective functions. And in this question, we are going to minimize it. So the function, let me provide a function here. Let me provide a function here. Slide that first. So the function we are going to do here is p. Going to do p is equal to 2x 2x plus 3y. So this is our so basically this is objective function that we are going to minimize. Minimize. So this is basically our objective function that we are going to minimize. Right. And then let me give the constraint. The constraint functions. First one is x plus y is greater or equal to is greater or equal to 2. Then the next one will be x plus 3, right? X plus 3, 3y will be equal to 12. Then the next one will be 3x plus y will also be less or equal to 12. Then the next one will be x is less or equal to x should be less greater or equal to 0. Then the next one will be y will be greater or equal to 0. So these are my constraint variables. So basically these are my, so okay, these are the questions we are going to solve. So we are going to optimize this objective function, which is p equals 2x plus 3y, which is our objective function, using this constraint function, that is x plus y equals greater or equal to 2, x plus 3y less or equal to 12, 3x plus y less or equal to 12, and then x plus x is greater or equal to 0, and y is also greater or equal to 0. So these are the questions that we are going to solve. So these are the questions we are going to solve. Don't run it here. Good. So the first thing we have to do is to grab the constraint function. So I'm going to grab, so to grab, just come to the input function, then just type the constraint function, which is the first one. So we are going to do it for all of them. So x plus y greater or equal to the variable sign. So we are having greater or equal to then 2. So you can see that it is being drawn there. So after that, after plotting all the constraint values, you have to plot their corresponding line. So in place of the inequality sign, they just put equal to them. So that is x plus y is equal to 2. So you're only putting that for you to draw a line there. So the reason for plotting their corresponding line is just to indicate a line there, because you are going to take off the inequalities there, right? So the next inequality is x plus 3y is less or equal to 12. So that one goes, so plot the corresponding distance of x plus 3y, 3y is equal to 12. So the next function is 3x plus y. So let's do a sum. Go to 12. So we go closer. The corresponding line will be 3x plus y equal to 4 again. So the next listen is x. X is greater or equal to 0 to 0. But the corresponding line is x is equal to the plot is the next equation is y is greater or equal to 0 to 0. Then it will be shown then plot the corresponding line y is equal to 0. It's greater. So you can see everything here. So what we are going to do is let's hide uh, all the inequalities given the equations. So B, we are hiding B, we are hiding C, so that everything can be clear. So that's the reason why we did that. So you can see everything here. So what next we are going to do is we're going to enter all those lines at the same time, all the inequalities at the same time. So what we do is so that to give us the shaded portion that will guide our optimization. So that's basically everything we are going to do. So our first inequality is because we are entering all of them at the same time. Our first inequality is going to be A, then your percent sign twice, then B. We do it for all like that. Then we do it for all. B. We do it for then E. So that's all. Then enter. So this is the region. So this becomes the constraint region that is guiding our optimization. Now we've gotten the constraint region that is guiding our optimization. The next thing we have to do is find the intersection, right? We're going to find the intersection of all the regions. What should I do? Just go to intersect here. Press on it. So I'm going to find for all the lines. So that is intersection. When you find the intersection for all the lines, when you find the intersection for all, you find my intersection for all my lines here. Then you can see all the intersection here. So now this is the intersection that is going to guide us to do our optimization. We are now done. Now we are going to do the next thing after finding the intersection of all the constraint variables. Now we are going to determine the value of the objective function at each of the intersected points. That's the key thing we are going to do. So after doing that, then we'll get our minimum value and then our maximum value. Basically, that's what we are going to do. So the next thing we are going to do is to go to the input field, then you type the objective function. Go to the input field, then you type the objective function. Maybe you have to go to right, then type the objective function, which is capital P. Objective function is capital P. Capital P is equal to capital P. Our capital P is equal to objective function that is 2x plus 3y. That is 2x plus 3y. 3y. So that is the differential. That's our objective function. P, that's S of x is equal to x. Oh, so sorry, my camera went off. So basically, you'll not be seeing my face from that place henceforth. Yes, I'll just find the solution to that. So after typing in the objective function, which is the P equals 2x plus 3y, now we are going to evaluate the objective function at each of the points of intersection. So the points of intersection are A, B, C, D, and E. So that's what we are going to do now. So we are having P. We are now going to evaluate the point, the value, the function P, that is the objective function at each of the points of intersection A, B, C, D, and E. So just go there. So A, type it, and B. You can see that when you are typing, you are getting what? The values of the function at each of the points, right? So P, that is B, you do it for all. Then P, that is C, you do it for all. P, that is D, you do it for it. Then P, that's up to E, up to point E, then do it for all. So you can see that these are all the values. These are all the values of the function at each of the intersected points. So now we are going to answer our question. Now, our question is, we are going to minimize the function. Right, so that's our optimization. I let you guys know from the beginning that if you are doing optimization, we are either minimizing or maximizing. For this question, we are going to what? Minimize. So for the minimize, just check the value of the function at various points and pick the least value. The least value there is your minimum value of that function. The function p equals 2x plus 3y. And if you want to pick the maximum, it's going to be what? The highest value, which is what? 15. So in this question, after doing everything, we can see that our minimum value for the function p equals 2x plus 3y is 4, right? And that 4 happens at the point D, So our minimum value is 4, and it occurs at the point D. That's 2, 0. So let me just mean the answer to this. The answer. The answer. That is 2, 0. So let me bring. So every time, make sure you go to move so that nothing. Let me bring the answer to the down. So basically, this is the answer to it, right? So when you want to find the maximum, you just pick your highest point. That's all. That's all. Let me omit the equations so that everything can be clear here. So basically, This is linear programming for us, how to solve questions under linear programming. So today we look at how to find or how to solve derivatives of a functions. This one to look at how to solve derivative of a function, and then we look at the sine function, which looks like this. So when you differentiate the sine function, you get cos, which is this. Then we went ahead to look at a cubic function, which is this. And when differentiating it, you are getting a quadratic. And also, we went ahead to look at a quadratic function, which the graph looks like this. And when you differentiate a quadratic function, you are going to get a line. And then we went ahead to take a linear function, right? So when we differentiate a linear function, you are going to get a constant, right, which is a straight line. And that's what we've gotten. And then we move on ahead to look at how to do linear programming. And we all know that, I let you guys know that a linear program provides a structured approach for making optimal decision in situations where the relationship between them must be linear. So the key term there is linear. If the relationship between them is not linear, then we are not looking at linear programming, right? Then I go ahead to let you know that in linear programming, it involves, or when you're optimizing, it involves two functions. That is objective functions and then the constraint function. We look at the objective functions to be the function that you are trying to optimize. And when optimize, you are either minimizing or you are maximizing. And this is a linear equation involving the decision variable. We look at the decision variables to be those variable whose value can adjust in finding our optimal solution, right? And someone will ask, what is optimization? It's the process of finding the best value for the decision variable. So the decision variable here, we are still talking about the constraint function that satisfy all the constraints, and either you are either minimizing or maximizing. Are you okay? So this will bring us to the end. Went ahead to construct all those things. And then the first thing you have to do is you have to input your constraint functions first. And after that, you draw their corresponding lines, enter all the constraint function as a goal into your GeoGebra app. Then what do you do? The shaded portion we are having here, the shaded portion we are having here becomes our optimal region, our constraint region, which is guiding our optimization. Are we okay? Then you find the intersection of all those lines at the constraint regions. You find the intersection of them, and then you go ahead to enter the objective function that we are trying to optimize. And after getting that, then you find the values of that objective function at each of the points of intersection, which we have our point of intersection to be A, B, C, D, and E. And then you look ahead when you are minimizing, then look for when you after finding the values of the function at each of the point, look at the minimum or the least one becomes a minimum value. And then you state the point at which you okay. When you're maximizing, then you look at the highest value, which becomes your maximum value. And then you look at what? The point at which is okay. Okay. So that will bring us to the end of today's class. Thank you all very much. Thank you very much. Thank you very much. And we'll see you another time. Bye bye. I love you all. And we'll meet another day. But keep on practicing. We also know that practice makes man perfect. Keep on practicing, and then everything will be on point. Thank you. Thank you once again. Bye.